Today we will be talking about adding and subtracting limits of accuracy. Now before you start this video, please make sure you know how to find the limits of accuracy for both discrete and continuous data. I've done a video on that if you want to have a check. Once you've learned how to find the limits of accuracy, there's a little extra that you can do in order to find out some more information about things. So let's have a look at this question here. We have two balls, ball A and ball B. Ball A weighs 10 kilograms to the nearest kilogram, and ball B weighs 4 kilograms to the nearest kilogram. The question is to find the limits of accuracy for the ball's combined weight. So what does that mean? That means that if you took ball A, found its weight, and added it to ball B, what are the limits of accuracy for its weight? The way that we solve this is first we have to look at the limits of accuracy for each of the balls separately. So let's find the limit of accuracy for A. We know this is going to be 9.5 is less than or equal to A, which is strictly less than 10.5. Good, and now we've got to find the one for B, and it's very similar. This one will be 3.5 is less than or equal to B, which is less than 4.5. Now that we've found the limits of accuracy, we need to ask ourselves, okay, when we combine the weights of these two balls together, what will the lower and upper bound be? Well, let's start with the lower bound. We'll call it LB. The lower bound will be, if you think about it, you'll take the lower bound of A and add that to the lower bound of B, because you want the balls to be the lightest so that their combined weight is also the lightest. So our lower bound will be 9.5 plus 3.5, which is 13. That's our lower bound. How about the upper bound? Well, it's very similar. If we want to add two weights together to get the biggest weight possible, we want to take the upper bound of each ball, because that will give us the greatest weight possible. So we'll have 10.5 and we'll add on 4.5, and that will give us 15. And so here are our lower bounds and upper bounds. Now that we have our lower bounds and upper bounds, it's time to write the limits of accuracy, and we know how to do that. It'll be 13 is less than or equal to the combined mass of A and B, so we'll do A plus B, and that will be strictly less than 15. The reason why it's strictly less than is because previously we had the strictly less than sign here and here, so that means that it also stays over here. And this is our answer to the question. Now that we've added them together, let's look about taking them away from each other. So what we're saying is that we want to find the limits of accuracy for the difference in the ball's weight. So if we take the weight of ball A and we take it away from the weight of ball B, what are the largest and smallest numbers that we can produce? So here are the limits of accuracy for A and B. The question I want to ask is, what is the lower bound of their difference? So we want to produce the smallest number possible by taking the weight of A away from the weight of B. So what would that look like? Well, if we took the lower bound of A, the smallest number, and we took that away from the largest number of B, we would end up with the smallest number. Give that a think for a moment. So the lower bound will be 9.5 minus 4.5, which is just 5. How about the upper bound? What is the largest difference you can make? Well, again, to make the largest difference, we're going to need the largest value of A possible, and we're going to need to take away the smallest amount. So we can see that we're going to need the upper bound of A and the lower bound of B. So that will look like 10.5 minus 3.5, which will give you 7. And now we have our upper and lower bounds. So now we have the upper and lower bounds, let's write the limits of accuracy. Now we need to be really careful here, because if you notice, in both the lower and upper bound, we use the strictly less than sign. So when we write the upper bound, it's going to be all strictly less than. So we're going to have 5 is strictly less than A minus B, and that will be strictly less than 7. And there's our answer. So now that we've done those questions, we can have a look at this scary bit of maths here and work out what it means. This is the general rule for adding and subtracting limits of accuracy. So let's have a read. If A and B lie in the limits A min is less than or equal to A, which is less than or equal to A max, and all that means is that A has this as its lower bound and this as its upper bound, and B has this as its lower bound and this as its upper bound, then when we are adding two things together, to find the minimum, we just need to add the lower bounds of each, A min and B min, and to find the maximum, we need to add the maximum of both, so A max and B max. And when we are subtracting them from each other, to find the minimum value, we need to take the minimum of A, and we need to take that away from the maximum of B to get the smallest value possible. And when we want to find the maximum, we need to take the maximum of A and take that away from the minimum of B to get the largest value possible. So that's it. Next up, we're going to look at multiplying and dividing limits of accuracy together.